time that have done a lot of things, but to teach dogs that quickly to sniff, I mean, there's dogs that sniff cancer. There's dogs that if you're diabetic, they can actually give you a sign that, hey, dude, you're about ready to have a seizure, so lay down. Like before the person even knows that their dog does, because we've heard of seeing eye dogs. There's dogs that if you're severely allergic to something, like nuts, there are dogs that can be let into the classroom. They can walk around the classroom and determine if there's any peanut residue that could send the person into serious trauma if they're allergic to peanut oil. The dogs that sniff cancer, you've heard those stories about the dogs that like kept pawing on the person's hip or something, and they found out that they had cancer in their hip. All kinds of cool things. So now there's, when I came home after Thanksgiving 5 years ago from the Atlanta, Georgia airport, which is one of the busiest airports this side of the country, like they put over 100,000 people through that airport the Sunday after Thanksgiving. You had to walk past 3 dogs. So there, I mean, these lines, I don't know how they did it. Strategic, somebody knowing what they were doing. These lines are coming from 3 or 4 different places in the airport, and instead of going through security, you like walked up and down, like is about an area like from here down to here is where the dogs were inside this rectangle, and you basically had to walk around this rectangle while the dogs walked up and down. And I think they were trained to sniff out like explosives. If you had explosives on your clothes or on your hands or anything, meaning that you might have put something in your bag. So they did it with dogs that day because it was much quicker. So I don't know about you, but that's pretty cool. So I want to read more about that. How did they get those dogs trained so quickly with COVID? Very interesting to know. All right, so today is Tuesday, and we are going to be reviewing probability. Probability. So up above here, these are the 5 basic rules. This rule 3 is basically the definition of probability. To find the probability of an event, you take the successes divided by the total events. And you guys can write on your purple pages right now and add this stuff. All right, complements probability will become important tomorrow. Rule 5, most of us, if you have this from the past, most of us have this line crossed out. Because I don't like you using that rule for the or. I like you using this general addition rule. So I would like you to, if it's not already, put a box around here and also put or and a U because or is union. We have what is called an an inclusive or. You can be both. It's somebody asking you, do you want sugar or cream or both for your coffee? You can have both. There are other ors in other places that are exclusive ors, but ours is an inclusive or. That's why we subtract the ones we've counted twice. And if some of what I'm saying is like, I have no idea what those words are coming out of her mouth, you need to let me know because this is a really important concept. And the reason I like this rule is because it works for both. Because what does it mean if A and B are disjoint? Who knows? If 2 events are disjoint.
Does that mean they're mutually exclusive?
Yes, and what the heck does that mean, Joe? Throwing out those big words like he knows what he's talking about.
Means that 2 events can coexist without depending on each other.
Yeah. Like, what is the probability that a 13-year-old will be donating blood, Amelia?
0.
0. You can't be 13 and donate blood at Kinston High School. I'm sure there are some 13-year-olds that have donated blood, especially if they have a relative that their blood types match. Do you know that you can donate your own blood before surgery? Anybody ever heard that? Why would you want to donate your own blood before surgery? Because, yeah, in case something goes wrong, you can get your own blood back. It'd be kind of safer than taking somebody else's, right? All right, so I don't know if you have this somewhere, but you should have off to the side the probability of A and B equals 0. And do you have a Chromebook that you can watch this on? Are you sure? Because you can even set the Chromebook up right there. And then you can always turn your desk out a tiny bit if you want. This is called disjoint. And I don't understand why you guys, students, have such a hard time with this, because disjoint sounds like it. It's disjoined. It's not joined. It's separate. But it's also called mutually exclusive. And that means there's no overlap. If you were to draw a Venn diagram of this, and I don't know if you have enough room to fit all this in, they would be separated. And something that's really important to know is if you're disjoint, there's no chance you are independent, which totally rocks our United States American world. Because we think independence means, well, we're independent. We have a Declaration of Independence. We're independent from England. We don't have anything to do with them. We're disjoint. No, I'm sorry, my friends. That's not what independence means. Our forefathers got it wrong. Right now, I have petitioned Congress to change the words, the title of the Declaration of Independence. I want them to change it to the Declaration of Mutually Exclusiveness, or the Declaration of Disjoint, because that's really the right term. But it's messed our brains up, so we think independence means separate, and that's not what independence means in statistics class. I was really just kidding. I don't have anything down there in Congress waiting for them to change that, but if I make a big stinking point about it, maybe you'll remember. All right. What else do I want you to remember? Right here, I want you to put warning. So many people, that's not how you spell warning, Mrs. Garrett. So many people use this incorrectly. When you're asked to find the and, when you are asked to find the and, oh, come on, just go away. There we go. When you are asked to find the and, you shouldn't be using multiplication unless you are told things are independent. And rarely are you told. When you're asked to find an and, usually what you want to do is just pick it off the table. All right? And then really there's only 2 independence rules. So let's just kind of cross one of those out and just put a box around here. And this is for proof of independence. Yes, I thought it was D-A-N-C-E for a moment there. But. All right. The other thing we should put somewhere is that and is the symbol upside down U, which I think is like how you start to make a capital A. Sort of. All right, somebody who, I think we're okay. Okay, so now that we have that marked up, is there anything else that somebody who has it from before that we wrote down? Oh yeah, let's put that down. This right here, rule 1 means that whenever you have capital P parenthesis, your answer must be 0 to 1. It can't be bigger than 1 and it can't be negative. So if you ever are doing probability and you get the answer 0.38, 3.8, that's not good. And if you get negative 0.29, that's not good. All right, so we are going to look at our packet. I'm sorry, are you guys all done with that? We're now going to look in the packet that says AP Review. The probability of somebody watching you is proportional to the stupidity of your actions. Isn't that right? I love the memes that say, I'm glad I'm 40 or 50 because all my stupid stuff wasn't caught on social media. Some of you post your own stupid stuff. Someday you might be sad. Just saying. Okay. We are going to look at page 2. This is an actual question from an AP Stats test. 2 years ago, there was a question very similar to this, and we'll look at that sometime. My students that year were like, oh, the second FRQ was so awesome, Mrs. Garrett. It was one of those tables. It was easy peasy, lemon squeezy. Well, they didn't say that, but they were excited it was easy. All right. It's talking about your education and where you get your news from. So this is something that's not on that sheet. It was from 2011, 12, and 13. Where do people get their news? And about 10 years ago, people still got most of their news from television. But now, where do you think people get most of their news? From social media or the internet or online apps, newspapers. We all know that those have kind of died, sadly. I don't know about you, but when I read a book, I still like to have it in my hands. I still like to have a textbook right beside me and not electronic, but that's probably just because I'm OLD. So I'm thinking that this television, if we did it right now, this would go way down and social media would go way up. And, you know, if the news comes from your cell phone, I'm sure that it's completely 100% accurate. And especially if it's on TV, it has to be true, right? When you look at News Channel 5 or Channel 3, we learned that is, a lot of news is not exactly true, and it's not really the news station's fault. It's just kind of who you interview and where you get your information from. All right, so let's take a look at this page. And I meant to double the page, and for some reason I did not, or did I? Did I double the page? Nope. Sort of. Okay. All right. So I'm going to randomly pick somebody to read that first paragraph for us, and when I say first paragraph, it's starting with an advertising agency. Mr. Dursett, you have been selected.
An advertising agency in a large city is conducting a survey of adults to investigate whether there is an association between highest level of education achievement and primary source for news. The company takes a random sample of 2,500 adults in the city. The results are shown in the table below.
All right, random sample is good. We always like random sampling. That makes things not biased, we hope. And if you have trouble with probability, the whole time you're doing a problem like this, think to yourself, all right, they just went out and got a random 250 adults. 2,500 adults. And now they're all sitting in a big auditorium. There's 2,500 adults sitting at a big auditorium. And somebody's going to go up to the mic and say, testing, testing. Hi, could you stand up if you graduated from college? Or if you get your news from the internet. So right away, there's a whole bunch of people going to stand up that graduated from college. They keep standing, and a few other people are going to stand up that get their news from the internet. All right? So we have to write down the notation. So let's put some shortcut abbreviations up here. I'm going to use N for newspaper, L for local TV, C for cable TV, I for internet. I'll use none for none. Let's use high school graduate with a superscript C for not. High school graduate, not. That's a compliment. It says high school graduate but not college graduate. I'm just going to put high school graduate there. And then I'm going to put college graduate, CG, there. Unless the sentence has the word given in it or conditional probability, your denominator is going to be 2500 until you get to conditional probability. All right, so this first one has an or. And because this is the first time that some of us have done this in a long time, what would the notation be? Amelia, what are you going to say? The probability of?
CG
Yep.
or I
Equals what?
equals,
Oh, geez, sorry. Hang on just a second. Let me get, okay, CG or I equals,
P of CG
yep,
plus P of I minus P of I and CG.
yep. I'm going to put CG and I, but that's okay. You're fine. Those are allowed to be mixed up. All right. I'm hoping that you remember why we have to do the subtraction. Because we have some people standing up twice right now, right? If we were going to count them all. Like if we counted all the college graduates in the auditorium, and then we said, okay, sit down, and now stand up if you get your information from the internet, and you counted all those people, okay, sit down. And then you said, please stand up if you're a college graduate or you get your news from the internet. There wouldn't be as many people standing up as the two groups separately, because some people stood up twice. If that's a hard concept for you, you need to make a note and get in touch with me and let me know you need extra help. Ordinarily, you do not have to put that notation out like that. I wanted you to do it right now because it's been a while. What you do need to do, I will be now placing in blue. I do want this first one, the probability of college graduate or internet. All right, what's the fraction for college graduate? Maddie.
College graduate is 694,2,500.
Yeah, what did you say for the first one?
690.
Yep. There are 693 people in the auditorium out of the 2,500 that graduated from college. All right, Jameson, how many people are internet news people?
687.
Yep. Out of?
2,500.
Yep. And now I have to subtract the people that are in those categories, and Mr. Volrath, what's that?
245.
Yep. Out of?
2,500.
All right. If I were going to do this in my calculator, which is probably a good thing for you to practice, I would add up the numerators first, 693 plus 687, subtract the 245, and I would find out there should be a total of 1,135 people standing up out of 2,500. And now we're going to calculate that decimal, so if you would divide those two, and I will randomly select somebody to give us that decimal. absolutely put at least 2 places, but if it's a short one, then give all of them. Kaden, what'd you get?
0.454.
Thank you. All right. Now, I'm going to be totally honest and open with you. There are some things I expect more of you than you actually have to do on the AP test. If this were an AP day, which it was back in 2010, the only thing you have to show to gain full credit, to gain an E on this, are these last 2 things. That fraction and that decimal answer gets you an E. If you just have the decimal answer, guess what you get? I. Well, then how do you get a P? Well, what if you didn't know that you should subtract the 245? So you put as your answer, give me a second, come on. You put 1380 out of 2500 because you forgot about subtracting the both. 1380 out of 2500 would get you a P. Because at least you knew what you were doing, you just forgot part of the formula. So why do I make you have notation and show all the work? Because I'm mean and that's the way it's going to be, and if you don't like it, then you can go find another AP statistics teacher. And because some of those fractions are going to come in extremely helpful here in a minute. So if this is a test in Mrs. Garrett's class, you got to have that notation, fractions. I don't really even care if you have that final fraction. I want to see the work before that one. And there's lots of reasons for that, but that's the way it's going to be. So just deal with it. All right, next one. Leah, can you read and give me the notation?
Like read the question.
Yeah, read the question.
If an adult is to be selected at random from this sample, what is the probability that the selected adult is a college graduate and retains needs primarily from the candidate?
Okay, the word and. You can't use that formula on your sheet because nowhere yet has the word independence shown up. Agreed? We have not said the word independence yet. So we're going to have to come up with another way to find this. So Leah, what's the form or what's the notation? The probability of what?
C, D, and I.
So that's the upside down U. Do you care if we put the upside down U or the word and? Nope. But just know what they both are. All right. So Leah, is there a way you can figure that out without a formula?
Yeah, if you just look at the chart where the 2 overlap,
Yep.
then you'll see the 245 where they both come together, and then you can figure out how to do it. So,
Yeah, hey, didn't we already do that up here? Oh, that could help you really quickly if you recognize that. And then when you divide that, I believe you get a repeater. Nope. Yep. What am I doing wrong? Clear. 2, 4, 5, divide. Oh, I'm subtracting. Divide 2500. What do you get?
Like 0.98.
Okay, it must be the next one that's a repeater. 0.098. Why do you put the 0 point stuff? Because that's what you're supposed to do so that people know, hey, there's a decimal point here, because otherwise I might just think it's a speck. I don't care if you do it or not, but I kind of have to do it being a teacher, and this goes out to the World Wide Web. And that's why all of your textbooks do that too. So you know that it's a decimal point and not just a speck on the paper.
do you want us to put the final decimal into a percentage?
Nope. I think it confuses the issue. I mean, you can, but I definitely want the decimal.
Okay.
If you feel better putting the percent then too, go for it. It won't bother.
Both on the AP test?
Nope. Nope, because it is, they ask for the probability, they don't ask for technically the percentage of the of the sample. If they ask what percent of the sample is, then you should change it into. But they ask for probability, so this is okay. All right, conditional probability. Dun, dun, dun. That means no longer will the 2,500 be my denominator. So I'm going to do this one. Conditional probability. What is the probability that a randomly selected adult obtains news from the internet given that the adult is a college graduate? So they're asking for this. Internet given college graduate. And right now, if you go to your table where it says conditional probability, it's going to give you this formula. And I say, that's going to mess you up. I don't think you should do this. Put an X through it. I think that messes you up. What I think you should remember is when you're doing conditional probability, you're focusing on the given. So you got 2,500 people there in the auditorium, and now the person comes up and says, excuse me, hello. I'm only interested in college graduates now, so everybody else can go. Goodbye, get out of here. Well, a heck of a lot of people are going to leave, right? Almost 2,000 people are going to get up and leave. It's more like 1,800, but it's close to 2,000. And now because Philip might have a magic foot, but I have a magic pen, right now they're saying, given that you're a college graduate, you're just focusing on that now. Everything else goes away. Given that you're a college graduate, how many are? 693. How many of those people get their news from the internet? 245. Does it always keep asking questions that are so related? Like, this is all about college graduates and internet news. It doesn't ask about anything else. Is it always like that? No, not always. On tonight's homework, it won't be. But there is a reason why the College Board does this on a question, because of what's coming in the last question, really. They want this question to only take you about 5 minutes to do, so you have lots of time to work on the other questions. So just so you know, it's not always like this. So, oops, nope, that's not my denominator now. My denominator was 693. And out of those people, it's 245. And I think this is a repeater. Is it 0.353535?
Yeah.
So I'm just going to write 0.3535 because I like having 3 or 4 decimals. I think it's because whenever I used tables growing up, when I was your age, these fancy calculators did not exist in life. We had calculators. I was so excited when my dad brought home a calculator for work. It was really cool and outstanding. And it was back in the day where metric was we were trying to go metric. But good old United States, man, we can't be metric. We're going to stay customary English. The rest of the world might be metric, but dang it, not us. We're going to do it the hard way. I think it was in the 80s. Does anybody know the history of metric system trying to be put into United States? Because I did my science fair project on the metric system. So I was like in middle school. So it was probably in the 70s. Yep, I wore my pilgrim hat in 1976 because we were 200 years old. Woohoo! And everybody wore pilgrim hats. All right, so it was in the late 70s sometime that there was this big push for us to go metric, but we didn't. So the only thing that stuck are 2 liters and what else? A lot of our cars are metric, so if you're a mechanic, you have to be able to have 2 sets of tools. What else stuck? We have 2 liters and there's something else common in our life that's metric. Does anybody know? What's your phone say, Stephen? Okay. So, yeah, that's conditional probability, and it's nice they gave you the word given because sometimes they try to give you tricky words without saying given. But I think they've gotten past that. So, independence. Woohoo! All right. So, if we look at our sheet, we have these two rules for independence. And I'm going to do both of them this time, but after this time, you only have to choose one of them. Okay. So, here we go. I'm going to put way 1 down and way 2. And if way 1 doesn't work, way 2 won't work and vice versa. But I like way 2 much better, that's why I'm saving it. So, to prove independence, you can say the probability of college graduate and internet, does that equal the probability of college graduate times the probability of internet? I'm asking myself that question. If that's true, we have independence. If it's not true, we don't. But let's think about this for a minute. If you're a college graduate, do you think it's more likely or less likely that you use the internet? Why would you say more likely? Because in college, oh, Maddie, were you volunteering?
No.
No? Who thinks they know why you're more likely to use the internet if you're a college graduate? Natalie?
So you're likely to have money to get internet?
Yep, and what else? That's a good thought. You're more likely to have the money for the internet. What else happens in college? Natalie's already offered a suggestion. What do you think you do as a college student? In a lot of your classes, you probably have to do what?
Use the internet.
For research and stuff, right? Yeah. So you're probably more comfortable with the internet. And you know where to go to trust your sources, because you've had to do that for 4 years to get your degree. All right. So if you look back up here, we've actually done all of those. This is going to be 245 out of 2,500. And college graduate was 693 out of 2,500. And internet was 678 out of 2,500. I'm sorry, was it 687? 687. And I know what this one is. This is 0.098 because I already had to calculate it. And maybe that's another reason Mrs. Garrett likes me to show all my fractions because it makes this work a little easier to do. I don't know what those two fractions are multiplied together yet, though. So we'll come back to that. How about way 2? For way 2, and this is the way I like to think about independence, and I almost like to think about it in the reverse order of what your paper has. So I'm going to say this. Is the probability of being on the internet equal to the probability of being on the internet, given that I've told you that somebody graduated from college? And the reason I chose that is because right here in C, do you see that I have the probability of I given CG? And you always need, for independence, the first event. Well, the probability of being on the internet is 687 out of 2,500. And I already know that this is 245 out of 693. I don't even really need to bring that down. You could just bring the 0.03535 down. And now let's divide 687 by 2,500. And some of you do that, and some of you multiply out these other fractions over here and see what we get. And don't forget to keep your masks up over your noses. A couple of you have let them slip. If you need a metal bar to help pinch it on your nose, I got those. They're free of charge. And then we're going to take a little brain break here in a second, as soon as we're done with this. All right. Hannah, did you get the 687 divided by 2,500?
0.275.
0.275 versus 3535. And now, really important, because I could hurt you if you don't remember to do this. I mean, what I'm asking you to do could hurt you if you don't remember to go back and say those are not equal. Put your not equal to sign through there. In fact, basically what that's telling me is that if the 2,500 people are in the auditorium, 27% of them use the internet, 27.5%, like you were asking about the percent. But if I tell you, hey, that person went to college, your mind changes. In fact, that decimal goes up about 8%. Oh, now it's 35% chance that they use the internet if you tell me that the person you just picked out of the audience is a college grad. All right, and Val, did you get these two multiplied together?
I did way too.
Okay, how about Natalie?
I got 0.276.
Those are not equal either, are they? So I'm going to put my not equal to signs through. And now you have to write this as the final conclusion, because that's not enough to let the people know that you understand independence. You have to write the following. The event obtaining news from internet and the event graduating from college or being a college graduate, however you want to put it, are not independent. Why? Because the probability of internet does not equal the probability of internet if I give you a little bit of more information. It's not because internet and college graduate aren't equal in their probabilities. It's because the relationship of the probability of using the internet isn't the same if you switch to people who are college graduates. Now, if you wanted to do way two, the only thing different down here, if you did this way, the only thing different down here would be because the probability of college graduate and internet does not equal the probability of college graduate times the probability of internet. I just think this right here is the easiest way for us to wrap our human brain around what independence means. In fact, you have a completely blank page on page 3. Well, not completely blank, but you have space on page 3 to write down this thing that I want you to remember. Are you okay with so far? You can tilt your desk out a little bit. All right, so this is what I want you to write on the blank page. You still need that, Stephen? You sure? Okay. Independence. Think this. I know the probability of an event. The probability of event equals something, equals, let's put in a number. And over on this side, I'm gonna do, here's an example. Maybe, if I can spell. The probability of taking AP stats is 50 out of 800 students at Kenston High School. We're gonna say there's 800 students at our high school, and I have 50 of you. I did have close to 75 of you, and then senior privilege kicked in, and while I'm happy for those seniors that aren't taking it because they get to sleep in or leave early, they're gonna be sad if they're going to college because they're gonna wish they would have taken the class. Even though, and I would have loved to have them here, even though that would have meant more papers for me to grade, because I just think you are going to be, I don't, if you're not thankful, let me know in a couple years. Because you're going to use it in at least 3, 4, maybe 5 college classes. You're going to use some of this AP statistics stuff. If you're taking economics, business, anything in engineering, psychology, sociology, you name it, there's a, oh, yeah, I already said economics. There's all kinds of probability. Okay. So I know that there's 50 out of 800 is point what? 0.06 something, I think. Weird. 0.0625. So only 6% of our high school this year, 6.25% of the high school is taking AP statistics. All right. So now I get a bit more information. So let's call that I for information. Is the probability of E, given that information, the same as it used to be? If my information doesn't change your mind in any way, shape, or form, then you have independence. But if the information you get changes your opinion, then you don't have independence. So now, what if I say F equals freshman? The probability that you're taking AP stats, given that you're in 9th grade. What is the probability of a freshman taking AP stats? 0. At this high school, here at Hudson High School, they always have a few. They had a 7th grader take it a couple years ago. He's now graduating. His parents said he couldn't go to college till he was 16 because he's like super genius, and they just didn't think he was ready at the age of 12 to be hanging out with the 20 and 19-year-olds. He's already taken differential equations and a bunch of other things online. He hangs out in the math lab and helps people when they come in. He finds it very challenging to help those who are challenged by mathematics. He's, what's his name? I forget. He's funny. He's a good kid. But like, he is fascinated by how some people can't get math as quickly as him. He just finds that absolutely intriguing. And my husband said he's actually pretty good. I know what his name is. I just remembered because I knew it was funny. I believe his name is Jacob Wiener. That might be another reason his parents didn't want him to go to college until maybe he was 16, so he could handle the abuse. All right. So this brought up something else very important. It is impossible to be disjoint and independent. There is not a set, or there are not 2 events in the whole wide universe that are both independent and disjoint at the same time. You can't be. And we just kind of proved it right here. Now, what if I change this to the probability of AP, stats, and 12th grade? Well, out of the 50 kids, nope. How many 12th graders do we have? Does anybody know what your senior class size is?
250.
250? 230? Okay. Out of 250 seniors, I did this last block, you would think I could remember. 6, 9, and 10. So what's 19 divided by 250? .076. Ooh, that's close. Yep, it's close, but it's not exactly equal. So even being a senior doesn't help you change your mind that much, but it does change your mind a tiny bit. All right, so I don't know if that helped with independence or not. The last thing I would like to write down is 2 events cannot be independent and disjoint. It's impossible. Cannot happen. Because if I know you're in one set, I know for sure you're not in the other if it's disjoint. So that helps me change my probability way down to 0. And this is now finally the last thing. We have to go back and finish this. That's not what we have to finish, it's this. Did we write that down? Or is that last block? We wrote this, the event thing. Oh, this is what I wanted to say. Does anybody know why I can't take a shortcut and just say the events? I think I did it on here. Why can't I take this shortcut? Why is this right here bad? Because some of you will try to write it as a shortcut because you're going to run out of lead in your pencil, but really I'll gift you a free one. Why do I insist that you write the event twice? Why are you not allowed to say the event obtaining news from the internet and being a college graduate are not independent?
Because the second one just means that's one event.
Yeah, this is the intersection event. College graduate and internet. When you put it with the and here, when you don't put the event a second time down, then they're thinking you're talking about the intersection, and that's not what we're talking about. So don't do that. Well, you can do it, but I'll take points off. You have the freedom to do anything you want to on your homework, and I have the freedom to not give you credit if it's not done like I know it should be done for your best understanding and your best ability to score points well. All right, everybody stand up. Work, you can go shake it off and get a drink or something. All right, I'm gonna stand up on this stool. Maybe. I think there's a chair somewhere. I better use the chair. I don't trust myself. Thank you. Someday I'll lose that. As soon as I feel like I'm never going virtual again, you won't have to sit beside that. All right. Put your hand out in front of you. Take your right hand and put it on your left ear. Take your left hand and put it on your forehead because it's supposed to be nose, but you know, that's mask area and we're not supposed to touch that. I'm going to say 1, 2, 3 out, switch. So we're going to say 1, 2, 3, put your hands out, and now switch them. So now your right hand should be on your head and your left hand should be on your right ear. Ready? 1, 2, 3, out, switch. Who knows what the trick is to being able to do it without, like some of us are just good, but if you're having trouble, what's the trick? Concentrate on just one hand. So like right now, I'm thinking to myself, forehead, 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 out, switch. And the other hand just kind of goes where it should. I think, at least my other hand does. Okay, ready? Put your fingers up. In the air like you just don't care. No, okay, ready? In, out, in, up, in, out, in, up. And now start one up and one out. In, switch. In, switch. In, switch, in, switch. And if that's easy for you, then let's go one step further. Start up and in. Switch, 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 switch. How can you do that? Because I've been doing it for 30 years. All right, one last thing to go over and then we are done for today. And First Block told me that this was a good thing to go over this. For some of you, I apologize if you're bored to tears. But so far, good review. Is it bringing back some? Hopefully there's something there to bring back. If there's nothing there coming back, you need to get in touch with me. All right. To the Venn. To the Venn. Venn diagram. There is no way to picture independence using a Venn diagram. You can picture disjoint, but you can't picture independence using a Venn. All right, so here we go. Let us use, Mr. Lauer, could you read this first sentence for us?
A survey of local villagers revealed that 58% of all families serve hot dogs at their 4th of July picnics, 23% celebrate with sparklers, and 7% do both.
All right, so I got my Venn. Everything in the Venn has to add up to what? 100% or 1. I got H for hot dog, S for sparkler, and who knows where you should always start if it is possible to start here, if the information is given. Start in the center. So what's the overlap? 0.07. If you want to just use 7 instead, you can, but then you're going to be turning your fractions back into decimals. All right, now the trick is the entire hamburger circle has to add up to what? The entire hamburger circle has to add up to 58, but you already have 7. So what's in the hamburger crescent? What's in the hot dog crescent? Only hot dogs, no sparklers. Yep. This is 0.51. Likewise, the sparkler circle should add up to 23, but I already have 7, so this is going to be Oh, I'm still on magic ink and it's going away. Okay, this should be 0.51 and this should be 0.16, right? 16%. And I'm almost ready to go, but there are some people that maybe don't celebrate with sparklers or hot dogs. So the whole thing's supposed to add up to 100%. I'm going to subtract 51 cents. That gets me down to 49. Subtract 7 from that. That gets me down to 42. Subtract 16 from the 42. And that gets me to 26. Everybody agree? I don't remember. I think we trust them, don't we? Yep. Okay. The probability that a randomly selected family served hot dogs at their 4th of July picnic. The probability of living in the hot dog circle, here we go, hot dog, sparkler, the whole hot dog circle is 0.58. Still got 7 minutes, so don't get excited. The probability that a randomly selected family served hot dogs and celebrated with sparklers, the probability of hot dog and sparkler is right in the middle. 0.07. All right, now we have a given. What is the probability that a randomly selected family served hot dogs given that they had the sparklers out on the table? The probability of hot dog given the sparklers were ready to go. That means your focus should only be on the what? The sparkler circle. So if I just go up to the sparkler circle right here, what percent of families are in that whole circle? 0.23, but the families I'm interested in the moment are what slice of the 0.23? The 0.07 part, right? So I have to do this. So this is going to be 0.07 divided by 0.23, and that I have to finally do a calculation for. I get 0.3043. Oh, I'm back on that ink that's leaving me. You technically don't have to put the H and the S on your circles, but if you come down here and do this by mistake, I'm not going to give you credit for that way because technically that is sparklers given that they have hot dogs out. So make sure, I just always put the letters on so that way my teacher doesn't have to guess if I'm doing it right or not. Are the events, hot dogs and sparklers, disjoint events? Nope, and here's what you have to write down for Mrs. Garrett. The probability, okay, so first I'm going to say no, because the probability of hot dog and sparkler is 0.07. If disjoint, the probability of hot dog and sparkler would equal 0. And that's what Mrs. Garrett wants, and the AP people want to know that you know that disjoint should mean there's a 0. No overlap. And the last one, independence. All right. I have an and up there. I have the H, but I don't have the S part to do it that way. But I do have a conditional. So I'm going to ask myself, is the probability of hot dog given sparkler equal to the probability of hot dog? And I put a question mark up there because I'm asking myself. Well, guys, I already got the numbers. This is easy peasy. Is 0.3043 equal to 0.58? Nope. So you better put a not equal to sign there. And then you have to write, because Mrs. Garrett's a meanie, the event serving hot dogs on a 4th of July picnic, but we're not going to write that down. And the event celebrating with sparklers are not independent because hot dog given sparkler does not equal hot dog. All right, so your 2 pink papers that were for homework today should be in your red folder. Rourke, you should have uploaded those somewhere. Either place is good for me. And your homework tonight is to do a Ben, Santa, and reindeer, do a table, which is on page 5 and 6, and then do the A's in your multiple choice packet. So you have another couple pages in this packet, page 5 and 6. Be careful because page 5 Ben is not as easy as this one. If you get stuck, go to the homework hints that will have the Ben answer there for you so you don't mess up the rest of the page. And then I can explain how I got the Ben if you need. And then yes, there is a page for you to practice partial credit multiple choice. I've circled the ones I want you to do work for in the multiple choice. I'm hoping that it really doesn't take you longer than, I'm guessing that the majority of us will do this in 15 to 30 minutes. How long did it take you, Steve? Oh, just kidding. I'm sorry, I'm just kidding. Does that bother you that I tease you? I think you can get it all out in your next class, though. I hear that that is your favorite class of the day. Should we warm up? Okay. Mommy me mo moo. Mommy me mo moo. Do you do that? Do you do mommy me mo moos in choir, or is that like back in the 80s, Mrs. Garrett? Give it up. No mommy me mo's? Who's in choir other than Stephen? Do we do mommy me mo? See? I know my stuff. And I know you don't sing in excelsis Deo, you sing in excelsis. For angels we have heard on high. Sing eggshells. Because it sounds like excelsis better than all when you're singing. Bits of unimportant knowledge that I know. All right, you can leave. Thanks. I hope that brought out some probability rememberings. We will do more probability tomorrow with tree diagrams. And it will be Wednesday. Woohoo! All right, Rourke, do you have any questions for me, bud? All I see is the monkey. See you tomorrow. I sent you the email this morning. Thank you. Thank you very much. Hey, Rourke, anything else?
I'm good.
All right. We'll see you tomorrow.
See you tomorrow. Have a good day.
Thanks, you too. Bye-bye.
Bye.
Mrs. Garrett, I have a stats question.
All right.
In bio, we're doing a lab, and we're comparing like the changes in volume, and we're soaking like gummy bears in water and salt water. Should we run a paired T test?
So what are you doing after you soaking them?
We're like measuring the change in volume.
So you first weigh them, and then you soak them, and then you weigh them again?
Well, we measured them and weighed them, yes. But we're measuring the change in volume, not weight.
Oh, so Are you measuring the first volume?
Yeah, we mentioned the first one.
How?
Probably like rulers and stuff.
Oh, so you calculated
Yeah, we calculated it.
length times width times height, and then you soak them in water and take them out and recalculate length times width times height. All right, I like that. Yeah, you should do a t-test.
Okay. Because that would like.
You should do a paired test, so you're doing differences.
Right.
Yeah, because you have those, yeah, so it's really not a two sample t, it's a one sample paired t-test.
Okay.
Because you can subtract take all of the volumes before and all of the volumes after and subtract them, and use that one list of data to see if it's, greater than zero, right?
Right, yeah.
Because zero would mean no change.
All right. I was just checking.
Yeah, you don't wanna do a two sample though, it's easier than that, because you have, it's not like you're taking all of them and just randomly, sporadically putting their volumes down and then
Right.
randomly, sporadically putting their volumes down afterwards. You actually have the pairing, so it would be a one sample t-test.
Okay. I'll have to refresh on that. I have my binder still, so.
Look for the one that, did the men and the women going and buying cars.
Okay.
That's a matched pairs t-test.
Okay, I'll look for that.
Yep. And if you can't find it, I can find it for you.
Good, thanks.
Yep,
I shared that thing from English with you.
yes, and I haven't looked at it.
No, that's all right.
I will
I just
now.
want to make
I
sure
will.
that you got it.
Yeah, I did, thank you.
I missed that. I don't know if it's, it sucks we only got like a few months.
Yes, and now I'm trying to bring together people from like 5 different takings of honor stat, because the people who took honor stat last spring were definitely, like, I don't know if they remember probability or not.
Yeah.
And then the people that just took it this fall, we were remote also, but we did take a test on it, so I think they got it a little better. But then there's people from 1 and 2 years ago who I know got it, but it's been a long time.
Right.
So it's like, these first 2 weeks are killing me. I can't
Yeah,
wait
sure.
to just start teaching like,
Different stuff.
yeah.
I like that.
Yeah, well, we haven't even done sampling. I mean,
Oh,
plus I'm
gotcha.
2 weeks behind and we haven't done sampling distributions yet.
Okay.
We haven't, I mean, it's gonna be another month before I start inference, and then it's gonna have to go like this.
Yeah, and
Well-
that's good to have all that practice too.
Right, and I'm hoping I don't have to review as much for the AP stat.
Is it? But the stats test is later, right?
Right, but I lose almost everybody.
Oh, right.
There's no mentorship,
Right.
but they're taking other AP tests.
Yeah.
And most of them are in the morning,
Yeah, it's.
so I have to be done with everything.
And
by-
we lost the 2 weeks from they pushing it back.
And we'll have a final exam this year, like we did last year, and that takes a good few days. It takes 2 days to take it,
Yeah.
couple of days, I mean, I
And
don't
this
know.
whole year's been whack.
Yep, we're just going to do the best we can.
All right, well, I'll come visit sometime again.
All right, Carter told you his story, right? About having to retake the test in August. McAbeer.
He did? I didn't know that.
His pictures never made it to where they were supposed to go. And
Yeah,
he found out at the beginning of August that he could either get his money back, or if he wanted to have a score, he had to retake it next week.
Gotcha.
So we studied, and he did well.
That's good.
Yeah,
A lot of people who did pictures had a hard time uploading them. That's why I tried to learn how to type all the stuff out.
right,
Which, I mean, it submitted, which was good, but
right.
it was hard to type, for sure.
I agree. All right,
All right, see ya.
see you later. Have a good afternoon. 30 to 35.